Now that you've seen a glimpse of why you'd want to use promises, it's time to start seeing promises in action. For most JavaScript developers, the first time they'll encounter promises is when they consume another library. An example of this is one of the most popular HTTP request libraries, Axios. At the time of this recording, it averages 6 million downloads a week. This library is an abstraction on top of the XML HTTP request calls that you saw in the last module. One of the key abstractions is that it is promise-based. That is, you can't use Axios without using promises. To see this in action, inside of your IDE, open the consuming.mjs file. Inside of the get function, add the following line. A quick side note, the Axios library is already included in this project and referenced in the HTML files, and that's why you have access here without doing an npm install. Next, run the command npm run dev. This will launch the web server so that we can see our code. If you go to localhost 3000, which is the root of the web server, you won't see our landing page. Instead, you'll see this API landing page for our JSON server API. However, if you go to /home, you will see the landing page for the course. Click on the Consuming Promises link, and that will take you to this page. We'll spend all of our time in this module on this page. Before continuing on, make sure that you have your console open. Now, run your function by clicking the Success Get button. Nothing on the website changed, but if you have XHR logging turned on, you'll see in the console that a request was made. If you don't have that turned on for the console, you can jump over to the Network tab and verify that that same request was made. This shows us that Axios did indeed make a request for us. I want to take a quick sidebar here. This is an example of what I meant earlier when I said that promises were eager, not lazy. We've not yet done anything to actually get the data from our promise, and yet it still kicked off a request to the API. So jumping back, what do we need to do to update our results in the box? Head back into your code. Earlier, we talked about how a promise can have 3 states: pending, fulfilled, or rejected. We want to handle the fulfilled state. That is, we want to make sure that when the request succeeds, we can access the data. To do that, we use a function named then. So add then to the end of your get command. When a promise is fulfilled, it will call then functions. Then takes a function as its only parameter, and this function is executed whenever the promise succeeds. So let's add that function now. Before we execute this, let's do a very brief walkthrough. Inside the function passed into then, we're destructuring the result that is passed back. In this case, Axios returns a result that has a lot of information about the request, such as headers. It places the payload in a property named data. That is, the data property contains our order that we just requested. Next, we're using the setText function, which is in the results.mjs file I mentioned in the last module. This function will take whatever data we give it and place it in our results box on the screen. In our case, we're just going to pass it a string version of the data that Axios retrieved for us. Switching back to the browser, reload the Consuming Promises page to make sure it has your up-to-date changes. And this time, when you click on the Success Get button, your response box will update with the details of the order for order number 1. And just like that, you've consumed your first promise. Let's look at the code quickly one more time before we continue on. This function is the essence of a promise. It starts by calling an asynchronous function. In this case, it's an HTTP GET request. Next, it chains a then function onto that request. Essentially, it's saying, after the GET completes, run this function next. Remember, part of the definition of a promise is that it handles the eventual completion of an asynchronous call. We're not concerned about when the then call happens, but we know it happens after the GET call succeeds. That works great when everything works, but what happens when your API request fails? You'll see how to handle errors next. There are countless ways for any asynchronous function to error out. Even in our case, with HTTP requests, you could get a 404, or a server error, or a handful of other status codes that indicate that the call was unsuccessful. Let's see how to handle those. Return to your IDE in the consuming.mjs file. This time, we'll be adding code to the getCatch function. But let's start by copying code from the get function above. We can use this as our starting point. After you paste it in, make a couple small tweaks. As I mentioned, the Axios library returns a lot of data as part of the result object. So let's change our function to pass in a result object and not just data. Next, let's examine the result.status code. This is the HTTP status code of the request, so let's add an if condition around our set text. This way, we can check our condition and set the text to an error if it was not a successful request. Now, let's force our request to be unsuccessful by requesting an order that we know does not exist. So change it from orders/1 to orders/123. With all that done, return to the browser and reload the consuming page. Click on the failed GET request. You'll notice that the results box didn't update. It still just says results. And in your console, you now have two errors. First, you have one for get HTTP localhost 3000 orders/123 is a 404. And the second one is that there is an uncaught error, specifically in the promise. And you can also see that the XHR request failed. The first error is expected. We're trying to get a record that we knew didn't exist, so we expected a 404 to come back. But the second error is unexpected. What does uncaught in promise mean? Returning to your IDE, recall the three states of a promise: pending, fulfilled, and rejected. The last clip showed how to handle a fulfilled promise. But this time, our promise wasn't fulfilled. It came back with an error, which means that we're in the rejected state. And the rejected state is not handled with the then function. So let's reset our code back to what it was at the beginning, and then change that ID back to 123 to make sure we get an error. What we need to do is call a different function to handle the rejected state. That function is named catch. So chain a .catch after the then function. Much like the then function, the catch function also takes an internal function. The internal function only needs one parameter, and that represents an error or reason. Whenever a promise is rejected, it will pass in a reason for why it was rejected. And all we want to do here is display that error. So we're going to use the same setText function to display our error. Refresh the consuming page, and one more time, click on that failed get button. Now the results box shows the error that the request failed with a 404. Additionally, when you look at your console, you should still see an error that the GET request returned a 404. And you should still see a message that the XHR request failed. But you should not see an uncaught in promise error, because you've now handled the error case of your promise. Briefly return to your code. Notice that inside the catch, all we're doing is displaying the error. That's pretty much solely for demonstration purposes. If this was a real application, you might take other actions here. What you do inside of your catch block is dependent upon the use case of your particular application. Additionally, what data the error or reason contains is up to the library that you're consuming. You've now seen a pretty simplistic usage of promises. But what about that case from earlier in the course where you needed to order your requests? Up next, I'll show you how you can handle that exact situation with promises. So far, you've seen the simple case of making a single asynchronous call and handling its success or failure. But let's be honest, you probably didn't need promises for that. You've been doing that on your own for a while. So how can promises help ensure that the right data is loaded when it's needed? One nice thing about promises is that the settled functions, the then and catch, both return promises. This means that you can chain your promises together. For example, if we were to look at our success code from earlier in the module, we could have our then return another value. Nothing special, any ordinary return value will work. And the then function will then wrap this return value in a promise, which means that we can chain another then to that function. Now when this code runs, it'll place the order on the screen, and then it would log out the word Pluralsight to the console. We'll leverage this ability to be able to sequence our data requests. Staying in that familiar consuming file, we'll modify the chain function for this clip. As we did in the last clip, let's copy the body of the get function to get started. This time, instead of displaying the order on the screen, we want to know what city is the order being shipped to. In order to do that, we need to first load the order, and then look up the shipping address in a second API call. Start by modifying the internal function of then. Delete the setText function call, and instead make a second axios.get call. Then, let's handle that call. We could add a .then, where we're at now, at the end of our second get. But now we're getting right back into that problem of the callback pyramid that we discussed before. So instead of chaining the then off of the second get, let's chain it off of the other then. With that code written, let's reload the consuming page in our browser. Before clicking on the Promise Chain button, think for a second about what you'll see. When you click the button, did you see your expected results? Were you expecting to see something like city, Omaha in the results? Instead, it still just says results. And down in the console, there's an error. So what's going on here? Why didn't it update the results? Remember that we just talked about how every then and catch returns promises and how that allows us to chain them? Well, that still happened here. But our first then, we didn't actually return anything. And what happens in JavaScript when you don't specify a return value? It returns undefined. And that undefined value gets wrapped into a promise and passed on to the second then. And then your code is trying to destructure data from an undefined and it fails. So how do we solve this? The answer is really simple, and it's another one of those things that I've forgotten to do more times than I'd like to admit. We have to make sure to return the axios.get call so that we're returning the correct promise. After you add the return statement and refresh the page, click on the promise chain one more time. This time, the results show up in the box to say city, Bowling Green. That is, order number 1 is going to ship out to Bowling Green, Kentucky. Look at the code one more time. Let's read this code from top to bottom. It's going to start by getting an order, then it's going to take that order and read an address, and then it's going to display the address. Our code is starting to become more clear and readable by using promises. And you can imagine how you could chain several promises together in this fashion, as long as you remember to return the promise in each then. But if you're like me and you forget sometimes, or more than sometimes if we're honest, I'll show you how you can handle that situation more gracefully in the next clip. Sometimes when you're chaining promises together, the unexpected can happen. And as you saw in the last clip, sometimes that can blow up. We saw that happen when it logged out the exception to the console. So how can you make that a little bit smoother? Staying inside the consume file in your IDE, this time we'll be writing code in the chain catch function. Start by copying the code from the chain function that you just wrote. But in order to get the error that we got in the last clip, make sure to delete this return in the first then function. This will ensure that we get the same destructuring error that we got last time. Next, we want to add a catch function. The question is, where do we want to add it? Well, let's start by placing it after the second then. Return to the browser and reload the page. And make sure to click on the Chain Catch button. When you do, you'll see the results block update with an error that it can't destructure data from an undefined or null value. This is the same error that we saw in our console last time. But as you look down in the console now, it's not there. That's because we've caught it in this promise chain and handled it by displaying the error to the user. Returning to our code, let's take a look at another way that we can use this catch function. start by adding back that return statement on our address so that it completes successfully. This time, inside of the second then, introduce an error by adding a .my after the data. That is, we're trying to get the city from the my object. Save this code, go back to the browser, and reload. Once again, click that chain catch button. Again, there's no console error this time, but the results block now shows cannot read property city of undefined. The catch that you added will catch any error in your stack. Looking at the code once more, you can see that the catch is the last statement in the chain. It'll catch any error in any of the previous calls. But what if you wanted more fine-grained control? Well, you can actually have that with catch. Instead of returning the data from the address call, have it throw an error. Then add a catch right after that first then. Notice that that first catch still returns data. And in fact, it's returning an object with a data parameter. If it did not return that, then the second catch block would also be hit when the second then block tried to destructure data. In this case, the first catch will only catch errors from the first then. However, the second catch will catch all of the errors from the first catch through the second then. To see this at work, change the return in the first catch to throw a new error. Then reload the consuming page and click the chain button one more time. The result block shows the text of second error, which is that second catch block that you just wrote. Going back to the code one last time, let's put everything back to the way it was. While you do have the power to catch at multiple locations, most of the time you'll probably just want one catch statement. If you do decide to add multiple catch statements in your chain, remember to make sure that you're handling the error thoroughly. Otherwise, if you just return undefined from your catch, your code will run into additional errors. As you start to chain promises together, you might want some code to run only one time after the entire chain is settled. You could have a lot of duplicated code in each then and catch block to ensure that you're capturing that the promise is completely settled. Or, as I'll show you next, you could accomplish that with a built-in promise function. We've already seen how to handle a promise getting fulfilled and what to do when a promise gets rejected. But what if you need to execute some code after a promise settles, but you don't care if it was successful or not? Thankfully, there's a function just for that. As we've already seen, one common case for consuming promises is using a library like Axios to make HTTP requests. And often, when applications are making HTTP requests, they like to show a loading indicator. And then once the call is fulfilled, they would want to hide the loading indicator. But we also want to make sure in those situations that the indicator is hidden when the call is rejected. I think we've all ran across a website that doesn't hide the indicator when there's an error, and you're unable to do anything. So we need to make sure that the indicator goes away whenever the promise is settled. However, we don't want to do it the instant a promise is resolved. We want to make sure all the code in our then and catch blocks completes before we hide the indicator, particularly if we have a long-running process in one of our then blocks. We don't want the indicator to disappear too quickly. So how do we handle this? Return to the consuming.mjs file, and by now you know the routine. We have one empty function left, so we'll be placing our code in that block in this clip. Start by pasting the code from the chain catch function into the function named final. Next, we want to show our loading indicator, and that's imported from our results file. So before you make the Axios request, call show waiting. Let's hop over to the browser and make sure that we know that the loading indicator is working before we continue. Refresh the app and click the Final button. When you do, a green box covers the screen and it says Waiting. So our loading indicator shows up, but unfortunately, it's not being hidden. Going back into the code, we have a couple choices. We could place our hide waiting function in the then block, or the catch block, or both. We already said that we need to make sure both states stop showing the waiting indicator. And we started our course by talking about producing good code, so it's probably best if we don't put it in each place, repeating our code. Thankfully, promises have a function just for this case. After the catch block, add a new function named finally. Inside this function, let's use a timeout to call our hide waiting. We normally wouldn't want to set a timeout for this, but for demonstration purposes, it'll let us see the waiting indicator for at least 1.5 seconds before it disappears. And then we're going to update our result to let us know that we're completely done. Return one more time to the browser and reload, and then click the Final Update button. You can see the waiting block show up. Then, after about 1.5 seconds, the box goes away and we see that our text has a -- completely done added to it. That's because our finally block waited until all our code was done and then ran. This allows you to run some asynchronous code, handle the success or failure case, and then run some final code. In our case, we're using that function to clean up our waiting indicator. Remember, there's 3 states to a promise. There's pending, fulfilled, and rejected. And in this module, you were able to see each of these 3 states. And more than that, you were able to see how to start chaining fulfilled and rejected states to handle the flow of data in your application. And that all works great if you're using a library like Axios that's already built on top of promises. But what if you want to work with an async function, like that set timeout that we just used in our finally block? Is there a way that you can turn that function into a promise? There is. In the next module, I'll show you exactly what you need to do to create your own promises, starting with set timeout.